prime factorization. Yep, because they asked you that. Prime factorization, which is also known as product of primes, which is also known affectionately as the tree thing. You'll remember this from last year. There are two different ways to do this. One of them is the tree thing, which we call the factor tree. And the other one is called division by primes. You'll get the same answer using both. Sometimes they'll ask you to use one, sometimes the other, and sometimes you'll get to pick which one you like. Okay? But how it works is like this, a factor tree. If you are asked to prime factorize 100, okay, what they're asking you to do is break down the number 100 so that it is nothing but all prime numbers multiplied together. In other words, this. Okay? You just kind of keep breaking it down until you get prime numbers. You start with 100. What times what gives you 100? Now, most people say 10 times 10. There are other ways, and you'll still get the same answer. Since neither one of these are prime, you need to break it down again. Well, what times what gives you 10? 2 times 5 and 2 times 5. Once you end up with a prime number at the bottom, you can stop, because you could put 2 times 1, but you could go on forever like that. Okay, so you don't use ones as any of your numbers there. 2 is a prime number, 5 is a prime number, 2 is a prime number, 5 is a prime number. They're all prime, so I can stop there. I recommend that once you stop there, you rewrite them up top here in order so that when I read them, because I'll read it like this, 2 times 2 times 5 times 5. If you were to remultiply these four numbers, you'll get 100. This is the product of primes that gives you 100. Jacob, question?
I did a little.
Well, you could have used 50 times 2 and then broke down 50 to 25 times 2. You don't have to use 10 and 10. Any two factors of 100 will work as long as they give you 100.
I got 5 times 5 times 5.
Well, 5 times 5 is 25, so
Yeah.
I don't know how you get 5 5s anywhere. Did you do split into 25 times 4? What did you, I started out with 100, what did you break that into?
50 and 50.
No, 50 times 50 is 25. It has to be multiplication, it's not addition.
Oh.
You can't break this into 50 times 50 because that's 2,500. It would have to be 50 times 2
Oh.
because that's 100. That happens all the time. Don't. Okay. Now, how is that different than division by primes? Division by primes looks like this. You're starting again with 100, but you're going to make this a bunch of division problems. It's just like it says, it's dividing always by a prime number. In other words, and here's where I start. If it's an even number, the easiest thing is always to divide by 2. So if I take 100 divided by my prime number 2, I end up with 50. And then you go to this one and it's the same thing. What can you divide 50 by? Well, if it's even again, I divide it by 2. That's another prime number, which is 25. Now 25 can't be divided by 2, so you have to try another prime number, Alexa, which is 5. If I divide 25 by 5, which is a prime number, I get 5. 5 on top is also a prime number, so I can stop. So there, all those circle numbers are my 4 prime numbers that give me 100. Gary?
Last year you called us the cake.
A cake? It is a cake.
Yeah.
I don't think that was my technical. You won't find that in many math books. Let's look at another one. 288. If I'm doing that, let's do that by division by primes. And again, dividing by 2 is easy because it's usually pretty easy to cut numbers in half. If you take 288 and cut it in half, you end up with 144. Again, an even number, so I would cut it in half again and get 72. 72 is still an even number, so I'll divide it in 2 again, which is 36. Some of you might actually have to do the division, maybe not so good to do this. Half of 36 is 18. Half of 18 is 9. Now we can't use 2 anymore, but 3 and 3.
Oh my gosh.
So you end up with 5 2s. And I think last year we probably used exponents maybe at this point. I don't remember.
Yeah.
This is the prime factorization of 288. If you come up with a number here that's not a prime number, let's say I got 4, you didn't do it right because you can't have a 4 in your answer. It has to be all prime factors. Every one of them has to be prime. It does seem like. Let's do one. I'll let you do one. The book even gives us one as one of the examples. Prime factorize 60 by using product of primes or division by primes. Go do the little cake, the cake thing, if you will. See what you get for the prime factorization of that. See what you get for the prime factorization of that. You got some answers over that somewhere? Calvin, what'd you come up with?
2 times 2 times 3 times 5.
2 times 2 times 3 times 5. So it should look like this. Divide by 2, you get 30. Divide by 2 again, you get 15. 15 is 3 times 5, so 2 times 2 times 3 times 5. Questions, problems, concerns, answers, exciting, unexciting?